You press a button. A motor starts. Feels instant. But that is wrong. Between your finger and that motor, there is a small computer called a PLC, and it does not react to your button. It reads your button once every 10 milliseconds, on a fixed schedule, whether you like it or not. That 10 millisecond window changes everything. Here is what actually happens inside. The PLC runs 3 steps, in order, forever. Step 1. Read all inputs and freeze them in memory. Step 2. Execute the logic against that frozen snapshot. Step 3. Write all outputs in one shot. Read. Execute. Write. This is the scan cycle. It never stops, never skips a step, and never changes order. The moment a new scan starts, the PLC takes a photograph of the field. Every push button, every limit switch, every sensor, its exact state at that instant, gets written into the input image table in memory. The PLC reads from this frozen copy for the entire scan. If anything changes in the field while the scan is running, the PLC does not know. It will see the new state next scan. Now the PLC walks the ladder logic, rung by rung, from top to bottom. For each rung, it checks the input image values, evaluates the contacts, and either energizes the coil or leaves it off. Power flows left to right, just like a relay circuit. The result goes into the output image table in memory. Nothing reaches the field yet. Only after every single rung has been evaluated does the PLC push outputs to the field, all of them, in one atomic write. If you press the button at the very start of this scan, your motor gets the command at the very end. One full scan cycle of output lag, typically 10 milliseconds. This is not a bug. It is the predictability that makes PLCs safe. Now here is something no wiring diagram shows you. A sensor sends a 5 millisecond pulse. The PLC scan takes 10 milliseconds. The pulse arrives and disappears entirely between 2 scans. The input image table never sees it. The PLC never knows it happened. This is not a malfunction. It is physics. Signals faster than the scan time are invisible to ladder logic. For those, you need hardware interrupts. In a live Yokogawa Centum VP or Siemens S7, there is a watchdog timer counting every scan. If one scan takes too long, an infinite loop in the logic, a network timeout, too much communication overhead, the watchdog fires. The controller trips to fault. Every output goes to its safe state. Valves close, motors stop. The process does not continue without a healthy scan. I have seen this stop a crude unit cold during startup. The PLC scan cycle. Read all inputs into a frozen snapshot. Execute every rung of logic against that snapshot. Write all outputs in one shot. Then repeat. Every 10 milliseconds, forever. Fast signals need hardware interrupts. Overloaded scans trip the watchdog. This cycle is not a detail. It is the foundation of every control system you will ever work on.